Let's take a look at these two examples. Remember what we said about the radicals, especially square roots. We do not want to see square roots in the denominator. So, like we did before, we are going to do also this time. We have to eliminate the radical from the denominator. But before I'm going to perform any operations, let me just remind you that we're supposed to apply conjugate. Let's say if I have binomial a plus b and I want to find the conjugate of it is a minus b. And for example, if I have binomial x minus y, the conjugate to x minus y is x plus y. Okay, you have to remember about conjugates. What I have to do first over here, I have to simply multiply numerator and denominator by the conjugate of this binomial. So I'm going to copy this down. I have 3 over x minus square root of 5 times conjugate of my denominator, which is x plus square root of 5, x plus square root of 5. You're supposed to remember the formula for the difference of the perfect squares, which says x square minus y square is equal x plus y times x minus y. If you are going to look at this formula, you will see that we have binomial multiply by its conjugate gives me x square minus y square, gives me the difference of two perfect squares. So what it means to my problem? Let's take a look. Anytime we multiply fractions, we have to multiply numerator by numerator and denominator by denominator. That's why I'm going to have 3 times x plus square root of 5. In the denominator, I'm going to apply this rule. This is my x and this is my y. That's why I'm going to write x squared, because according to the rule x has to be squared and my second term has to be also squared. So that's why I'm going to have square root of 5 to the second power. I'm going to distribute this 3 into the parentheses, and I'm going to have 3x plus 3 square root of 5. X squared minus square root of 5 raised to the second power. This exponent is going to cancel out my radical sign, and I'm going to have 5 over here. As you can see, at the beginning we had square root in the denominator. At the end, we do not have radical anymore in the denominator. That's why this is the solution to my problem. Let's take a look at the second example. Again, we have radicals in the denominator. We have square root of 6 and square root of 7. We want to eliminate them. What we're supposed to do? Again, I have to multiply numerator and denominator by the conjugate of the denominator. Let me copy this down one more time. Square root of 6 minus square root of 7. The conjugate to my denominator is going to be square root of 6 plus square root of 7. Whatever I did for my denominator, I have to do also for the numerator. That's why I'm going to have square root of 6 plus square root of 7 in the numerator. Next, realize that we have fractions. Anytime we multiply fractions, we have to multiply numerator by numerator and denominator by denominator. So I'm going to have square root of 6 times square root of 6 plus square root of 7. Now, I'm going to apply this rule into my problem. This is my x and this is my y. The formula says anytime I have binomial multiply by its conjugate, my answer is first term squared minus the second term squared. So that's why I'm going to have square root of 6 to the second power minus square root of 7 to the second power. This is going to be equal. I have to distribute this square root of 6 into the parentheses. Okay? Square root of 6 times square root of 6 is square root of 6 to the second power and plus square root of 6 times square root of 7. I'm doing everything step by step. Divide by. Second power is going to eliminate my radical sign. And this exponent is going to eliminate my radical sign also. That's why I'm going to have 6 minus 7 in the denominator equals. Now this exponent is going to eliminate my radical sign. And I'm going to have 6 plus. Now I'm going to use the properties of radicals. And I'm going to write these two numbers under square root, 6 times 7, over 6 minus 7 is equal negative 1, equals 6 plus square root 6 times 7 is equal 42 over negative 1. We cannot add 6 to square root of 42. So what I'm going to do right now, I'm going to divide every single number from the numerator by negative 1. So I'm going to have 6 divided by negative 1 plus square root of 42 divided by negative 1. This is equal. Positive, indivisible positive divided by negative is negative. 6 divided by 1 is 6. Positive divided by negative is negative. Square root of 42 divided by 1 is square root of 42. And this is the solution to my problem.